Students, in the previous lecture, we have discussed about the types of the slopes and its stability. Now, what are the different types of slopes? There are two types of slopes which are majorly distributed as infinite slopes. Infinite slopes are the slopes which are homogeneous and having a length variance. Generally, a natural slopes are the example of it. Natural slopes are the examples of each. Natural slopes including hills, mountains, these are the comes under the infinite slope. Then another is a finite slope, where the dimensions are restricted, and these are the slopes that are called as man-made slopes. Now, what are man-made slopes? That is embankment, then dams, canals. These are the slopes which are called as finite slope, and these are the man-made slopes. Now, always remember that here, whatever is the dimension, whatever is the angle of the slope. Suppose I will consider this is the angle of the slopes, and this is the height of a slope. This angle is called as beta. This angle is called as beta. Beta is the angle of inclination of the slope. When the slope is a stable slope, then this beta is less than the phi. This phi is angle of reverse. Angle of reverse. So when this beta is less than, when beta is less than phi, then beta is less than phi, it is called as flat slope. And this beta is greater than phi, then it will be called as a steep slope. Always remember that these steep slopes are more dangerous as compared to flat slopes. Therefore, whatever man-made slopes are a flat slopes. These finite slopes or man-made slopes are the flat slopes. As these are the flat slopes, its stability is more as compared to the steep slopes. As compared to steep slopes, and therefore, when there is a infinite slopes such as hills and mountains, where the angle of inclination is large and that is more than the beta, then it will be called as steep slopes, and steep slopes are less stable as compared to the man-made slopes, which are finite slopes. Therefore, beta is an important integral part of the slope stability. When beta is less, stability is more. Beta is more, stability is less. There is an inverse relation in between the beta and its stability, right? So here we will just consider the infinite slope that also we have discussed in the previous lecture. I will just give you a brief about it, right? So here I will just consider a slope. This is considered to be the slopes. This slope is an angle beta. This is the height of the slope h. Now here I will consider a small thickness or the small width of the section, where we will consider there is a small section that we will consider over here. This is the small width which we will take into consideration, where B is the width of the image and this Z is the height of the image. Now this is the small weight that we will take into consideration. Always remember that there are two factors which are affect on it. One is the activating movement and the another is the resisting movement. Now tell me which is one is the activating movement. Activating movement is the moment or the force which is responsible to cause failure. So here, which part is more dangerous, which will cause a failure of the structure? So this is the self-weight of this weight. So I will just consider this ABCD is the small page of dimension B and Z is the depth, that will be considered where the sulfate of the soil is a most important one. This is W. This W causes a sliding of the soil mass. If this more, then there is a sliding of the soil mass in the direction of gravity. Always remember that when there is a sliding, there is a resisting force also. There is a resisting force also. This is the activating force. This is activating force. And this is the resisting force. Now tell me whether there is a shear strength. We will consider the shear strength of the soil. Shear strength of the soil. This shear strength of soil is considered as a resisting force. And which is considered to be the activating. So shear strength of the soil is a resisting one, whereas activating force is activating force is shear stress. Shear stress. And in this case, here what is factor of safety? Factor of safety is equal to shear strength upon shear stress. Shear strength upon shear stress. So these things we have already discussed in the previous lecture. Now we will just directly come to the part. What is the equation of shear strength? What is the equation of shear strength? Equation of shear strength is equal to C plus sigma tan. Shear strength is tau F is equal to C plus sigma tan phi. What is C? C stands for cohesion and phi stands for friction. So here we will just assume this is the equation for the stability of the slope. Now we will just consider the factor of safety of a soil for different cases of the soil. Here we will just consider the different cases of the soil mass. So first, stability analysis of infinite slope. First, stability analysis of infinite slope. Stability analysis of infinite slope. Now, in the infinite slope, first we will consider the case of cohesionless slope. Cohesionless soil. When there is a cohesionless soil, the value of C is considered as 0. In the cohesionless soil, C is considered as 0. If C is equal to 0, then what is the shear strength? Tau F is equal to C plus sigma tan phi. As the sigma in C is equal to 0, therefore tau F is sigma tan phi. Tau F is sigma tan phi. Now, what is the shear strength? What is shear stress? Tau F is this. Then what is shear stress? Shear stress is, here we have considered, in the previous one we have considered, this is the small weight of the soil where it is subjected to W, and here we have just considered, this is the normal one, this is normal force, and this is the tangential force which is denoted as a tau. This is tau. This is the shear stress. Shear stress is moving in the downward direction, and here this resisting the tau wave is moving in the opposite direction. So how you will get this tau? Tau is basically the sigma tan phi. Tau is basically the sigma tan I. I is the angle of inclination, that is sigma tan I or beta. So here this tau is equal to sigma into tan of beta. Sigma into tan of beta. So how this term is sigma tan beta, that we have already discussed in the previous lecture. Now what is factor of safety? And therefore factor of safety is equal to tau f upon tau. What is tau f? It is shear strength divided by shear stress. So in this case, it is equal to sigma tan phi divided by sigma tan beta. So in this case, this is called to be a factor of safety. So here the sigma is getting cancelled, and therefore the factor of safety for the sandy soil is considered as tan phi upon tan beta. Tan phi upon tan beta. Right? This is the first case where we have considered the soil mass is the homogeneous soil mass, which is in a completely case of a cohesion based soil where the value of C is taken as 0, right? So the next case we will take into consideration, that is for then we will consider it for the next case, that is for the C5 soil. Here the second case we will consider it for the C5 soil. For C5 soil. Now if there is a C5 soil, here for the C and phi soil. If the soil is a C5 soil, this soil possesses both shear strength and both the cohesion as well as the friction. Right? Therefore, whenever there is a consideration of factor of safety, again, what is tau f and what is tau? So here this tau f is C plus sigma tan phi. This C is this shear strength is equal to C plus sigma tan phi, whereas here this tau is considered to be Cm plus sigma into tan phi. Now what is phi? Phi is the mobilized cohesion. Phi m is the mobilized cohesion which is taken into consideration. Right? Here S is the here tau f is the shear strength, C is stands for cohesion, sigma is the normal stress, effective stress, right? And therefore, here this factor of safety is equal to tan phi upon tan phi m. This is the mobilized cohesion or mobilized angle of shearing resistance. Right? Now, Then we will consider the third case where the soil is a purely cohesive soil. Third one is the soil is a purely cohesive soil. Purely cohesive soil. When the soil is a purely cohesive soil, the value of phi is taken as 0. Value is taken as 0. If this phi is 0, so naturally, what is shear stress? Tau f is equal to C plus sigma tan phi. As this phi is 0, as this phi is 0, therefore the whole term is 0, and therefore tau f is equal to C only. Tau f is equal to Cn, whereas tau is equal to Cn. Tau is equal to Cn. Then what is the factor of safety? Factor of safety is C upon Cn. Now what is C and what is Cn? C is the cohesion and Cn is the mobilized cohesion in the soil. Right? So these are the some small simple cases of the soil we will take into consideration. Further we will discuss the conditions where there is an entry or existence of the moisture, water content. If this is the condition when there is a soil is in completely dry condition, no effect of the water table is in the condition. Always remember that water is again anytime I told you water is the enemy of civil engineering or enemy of a soil. When there is an entry of the moisture, there is a reduction in the strength of the soil as well as increase in the stresses, and therefore most of the failures occurs in the soil in rainy season. As we know, plain ground is much safer than the sloping ground, because sloping ground is considered as unstable soil mass, and unstable soil mass is always a very dangerous. If there is an unstable soil mass such as slopes, when it is subjected to entry of the moisture or when the soil is in a saturated condition, always remember that there is a increase in the stress and reduction in the strength due to loss of cohesion, and the stresses are increased due to the sulfate of the soil is increased. And therefore, most of the cases, failures in the sloping ground occurs in rainy season, and that is called as a whole soil mass. That is the bulk soil mass is coming in the downward and outward direction. Downward and outward direction, which is called as landslides. As we know, here suppose there is a sloping ground given and there is a entry of the water content, not entry of moisture. Entry of moisture. Entry of moisture first reduces the strength and increase in the stresses. Increases in the stresses. Due to both these things, the result in failure of the soil mass. Failure of soil mass. When there is a failure of the soil mass, which is outward and downward movement of the soil. Outward and downward movement of soil mass, and that is called as landslide. Therefore, in most of the cases, landslides are occur in the rainy season, and mostly when there is a hilly areas due to the continuous snowfall. Many times the slope is getting steepened like this, and in that case, there is an outward and downward movement of the soil mass. Always remember that outward and downward movement of the soil mass, which is called as landslide. And In the sloping ground, always remember that failure surface is an arc of surface. Failure surface, which is in all the previous cases, it is a linear one. It may be an inclined one. But here, when we are considering the sloping ground, always remember that failure surface is a arc of an circle. Right? So this is the condition where the stability of the soil mass is changes. Here we will consider the numerical a new canal is excavated. We just have an interval. A new canal is excavated to a depth of 5 meters below ground level through a soil having the following characteristics. Here, there is a canal structure. Canal structure of properties C is equal to 14 kilonewton per meter square. Phi is 15 degree. E is given as 0.8 and G is given as 2.7. So is 1:1. So which 1:1? Calculate a factor of safety with respect to cohesion when factor of safety with respect to cohesion when canal runs full, when canal runs full and in sudden drawdown condition. Sudden drawdown condition. Always remember that this condition is the worst condition is considered. These two conditions are a worst condition where the canal is completely in a full condition and another is in a completely sudden drawdown condition. What is canal? Canal is the structure. Canal is the structures which is excavated into the soil to carry out the water from the source to the destinations and different destinations. Source will be a dam and then it will be carried out with the help of a canal which are just supplying the water to the farms. Now here, as the canal is excavated of height h, here the slope of the canal is given as 1:1. The factor of safety is calculated for the worst condition. Factor of safety is calculated for the worst condition when the canal is completely filled with water. So this condition is called as canal runs full. This is canal runs full. Full of its capacity. What is the capacity of this? Actually, this water level is not like this. It will be like this because some free mode is taken into consideration. Free mode. This is the canal condition where canal moving or canal is going with full of its capacity. Water is completely filled into it and the soil becomes a submerged soil. Now here the soil becomes the submerged one because the water level is above that. right? And the another condition here, this condition is called as empty condition, when due to certain failure, if the complete water from the canal is moved out immediately, that is sudden drawdown. I am just talking about the sudden drawdown. Immediately the whole water is getting drained out. So this condition is called as sudden drawdown condition. Sudden drawdown condition. So both these conditions are considered to be the severe condition or the critical worst condition where the canal stability has to be checked. Right? Now, here instead of giving the value of different values of densities, instead of giving the value of density, the E value, that is void ratio and specific gravity of the soil, is given. Right? And therefore, we can indirectly calculate the density of the soil. So what is here? We will just consider gamma W is 9.81 kilonewton per meter cube. So what is the density of the soil? Gamma saturated is equal to G plus E into SR upon 1 plus E into gamma into gamma. Now what is G? G is the specific gravity, is the void ratio, and SR is the degree of saturation. Here soil is in completely saturated condition. Soil is in a completely saturated condition. Therefore, SR is equal to 100%. As it is in a completely saturated condition, therefore we are considering SR is 0, SR is 100%. When it is in a completely dry condition, SR value will be 0. Right? And therefore, it is taken as 1. So with the same equation, we will just put the value of it, gamma saturated is equal to 2.7 plus 0.8 upon 1 plus 0.8 into 9.81, which is the density of the water. Now here we can have this gamma saturated is equal to 19.08 kilonewton per meter. So this is the saturated density. But earlier I told you that when the water table lies above the soil, means the soil is in a submerged condition. When the soil is in a submerged condition, its density is reduced as the buoyancy force is acting on it, and that is equal to the weight of the water displaced during its immersion. So here we will consider gamma submerged. Gamma submerged is equal to gamma saturated minus gamma double. Now we will calculate gamma submerged is equal to 9.27 kilonewton per meter. So this is the first part of it. Now then we will consider the two cases when the soil is in a completely submerged condition. As what is given slope for the canal is given as 1:1. Slope for the canal is given as 1:1. Means what is the angle? Angle I is how much? I is equal to 45 degree. 1:1 is given, so it is 45 degree. And then we will consider the first case, that is the case of submerged condition. Case 1. Case 1, that is submerged condition of soil. Which is considered to be the submerged condition of the soil? When canal runs full. Canal runs full. This it is in completely its fullest capacity, it is going to be run. So in such cases, we will be required a stability number, as the stability chart number, which is denoted by LS and depends upon the angle beta, and the another is angle of shearing resistance phi. So depending upon the beta and phi, we will calculate the stability number Sn from graph or from the table which is given. So for I it's 45 and phi is 50, Sn is found to be 0.083. 0.083. Now what is factor of safety? Fc is equal to C upon gamma submerged into H upon Sn. And here we will get the C value is 14, gamma submerged is given as 9.27, H is 5, and it is found to be 3.64. 3.64. So this is the stability which we will obtain in case of the condition. Now here for the sudden drawdown condition, we will calculate the mobilized cohesion where the factor of safety is taken as 1. So in this case, factor of safety for the submerged condition is found to be 3.64. So here for the sudden drawdown condition, sudden drawdown condition, here this phi W is gamma dash upon gamma saturated into phi. So in this case, we can just find out this phi W submerged is 9.27 divided by 19.08 multiplied by 15. So it is found to be 7.3. Now again we will find out the stability number. Now stability number for beta is equal to 45 and phi m is equal to, or it will be phi w, that is the phi w when there is a entry of the moisture, that is 7.2. So Sn is found to be, from the graph, Sn is found to be 0.122. And therefore we will calculate the factor of safety is equal to C upon gamma saturated into H into Sn. Now what is the change in the equation? Here in the first condition, now always remember that when we are considering the complete submerged soil, in that case we will just consider gamma dash. In the previous case we have considered this is gamma submerged. So here, if suppose your canal runs full, means the water table is above the soil. This is gamma submerged condition. This is gamma submerged. Therefore, when we have calculated the factor of safety, here we have considered gamma submerged multiplied by H multiplied by Sn. But when the water is completely drained out, and this is the condition. Sudden, I am just talking about sudden drawdown. If suppose we will consider the empty canal in the summer season, in that case this condition is different. Here instead of gamma sat, it will be gamma dry. But here the soil, the water is emptied suddenly, or the canal is emptied suddenly. but the soil is remain in a gamma saturated condition. Remain in a saturated condition. Therefore, in the previous one, when the canal runs full, we had considered gamma submerged, and here now at sudden drawdown condition, we will consider this is gamma saturated into H into Sn. Now calculate it, and here you can find the value of factor of safety is 1.2. Here we will just put all the values into the equation, and here the factor of safety value is going to be 1.2. So this condition is considered to be the more dangerous condition when there is the water is suddenly and completely empty. I think this is clear for you. The similar kind of problem, another problem. Similar kind of problem. When there is a temporary cut, temporary cut, 8-meter dip, 8-meter dip made into the clay. In clay, made into the clay of unit weight, gamma is 18 kilonewton per meter square. Then C is 20 kilonewton per meter square. Then it is found to be a rock layer is at 12-meter depth from the ground level. 12-meter depth from the ground level. The slope of cut is found to be 30 degree. Slope of cut is found to be 30 degree. And the factor of safety is given in this numerical. Factor of safety is given in this numerical. Here you have to find a safe slope. Now, if the slope is 30 degree, for this slope 30 degree and phi is 0, as the soil is completely clay, soil is a completely clay soil is there. In that case, your phi value is 0 and the slope for cut is given as 30 degree and phi is 0 for which the stability number Sn is given. When the phi is 0 and beta is 30, you have to find out the stability number. The stability number is given as 0.16. So this much data is given to you. In this case, you have to find out the factor of safety. Here, we will just, from the stability chart, we will just write down first Fc is equal to C upon Sn into gamma into H. Fc is equal to factor of safety for cohesion. What is Fc? Fc is the factor of safety for cohesion, where C is the cohesive, as the soil is completely a cohesive soil. Therefore, C is the only shear strength parameter. Then all these parameters are given. So Fc is equal to 20 upon 0.169 multiplied by 18 multiplied by 18 multiplied by 8. So here this Fc is found to be 0.8. Now C, you have to find out in this numerical, you have to find out the safe slope. You have to find out the safe slope. What do you think? The safe, whatever safe slope at this stage we have provided is not the safe one, or it is the safe? It is not safe. Why not safe? Because we have calculated the factor of safety, and that factor of safety is 0.85. This it is more than, or it is less than 1. Less than 1. Even 1 is not the same. 1 is a critical slope. 1 is critical slope, means the soil is at the verge of the failure, means whatever strength of the soil, same is the stress of the soil, and therefore a small increase in the stress may cause the failure, small reduction in the strength may cause failure, means it is at the verge of the failure, where the factor of safety is 1, that slope is considered as a critical slope. Always remember, that slope is considered as a critical slope, and therefore we always want the safe slope is more than 1. Safe slope is more than 1. So in this case, we will just calculate. Now, the proposed slope is therefore unsafe, as this slope is 0.85. Factor of safety is 0.85. Means the proposed slope is a unsafe slope. It's a unsafe slope, and in the one it is mentioned that you will be required the factor of safety is 1.25. Factor of safety is required to be 1.25. So in this case, we will make the back calculations. We'll make the back calculations for safe slope. Safe slope is equal to 1.25. Factor of safety is 1.25. Therefore, Sn is equal to C upon Fc into gamma into H. So here we will make the back calculation. In this case, Fc is taken to be 1.25, gamma is 18 and H is 8. C is already given as 20. Here we will find out the value of Sn is 0.1. So Sn is found to be 0.1. So from this value of Sn, find the slope angle. Find the slope angle. Why slope angle? Because phi is already 0. Soil is a purely cohesive soil, therefore phi is equal to 0, and therefore we will just find out from this back calculation. Again, we will go over the graph and calculate the value of the beta, and that beta is found to be 12 degree. Just remember, for 30-degree slope, there will not be any change in the phi, because we have already mentioned the soil is a purely cohesive soil. As the soil is purely cohesive soil, the value of phi will be 0. In that case, phi is constant, and here the inclination angle is given as 30. So for 30, beta 30 and phi 0, we have calculated the factor of safety. If this factor of safety is more than 1, in that case no issue. But here the factor of safety value is found to be 0.85, and the safe slope we required is 1.25. So we will make a back calculation and we will calculate it one more time and then find out the beta value. And from the beta, it is observed that the soil is the angle of inclination for beta has to be taken as the 12 degree, then only your factor of safety value will be more than 1.25, and the slope is a safe slope. You just go through this. We'll have a more numerical. Just we'll have another data. Embankment retained incline at an angle of 35. Here, the embankment this is an embankment. What is this? This is an embankment. This embankment is angle is 35 degree. Angle is given as 35 degree, which is beta, and its height is given as 15. Height of an embankment is given as 15 meters, where C value is given as 20 kilonewton per meter square. Value of gamma is taken as 18 kilonewton per meter square. Here, as the soil is given as a clay soil, soil is given as clay. If soil is given as clay, what will be the value of phi? Phi value is 0. Phi value is 0. If phi value is 0, for I is for beta is 45 and phi is 0, Sn is calculated. Sn is given in the numerical. So Sn is calculated and given as 0.06. Sn is given as 0.06. Now what is the equation? Again, it is a purely cohesive soil equation for Fc is equal to C upon Sn into gamma into H. Sn into gamma into H, and therefore here we will just put all the values into the equation. Here this is 20 divided by 0.06 multiplied by 18 multiplied by 50. So find here the factor of safety value is taken as 1.23. Fc is taken as 1.2. Some of the time the conditions are given. Some of the time the conditions are given because nothing is mentioned about the clay soil or nothing is mentioned about the phi soil, and many times students are getting confused if phi value is not given. So if phi value is not given, but it should be mentioned that the soil is a purely cohesive soil, you have to take the value of phi is 0 and Sn is the stability number, where this equation of stability number is applicable only for the cohesive soil. And then we will calculate the Fc. Now hereafter, we will just start the next part where we will consider the seepage of the soil.